All right, welcome there, calculus folks. We're nearing the end of our calculus time. This is the last calculus lesson, believe it or not. Pretty busy day. The warm up involves a couple of things here. First of all, uh, remembering these fundamental limits that we've been using to prove these awesome derivatives from first principles. And again, I said what you have to do is you just have to remember what their values are. Now, the question is, do you remember what their values are? And this one is 1. This one is 1. And again, this one is the one that we sort of poke the lawn outside, and then this ends up being the definition of E. So the ln of E is just 1. This was the one that we use using the squeeze theorem is 1, and this one is 0. Cos is always the weird one. It seems like it's the one that's doesn't work nice. So what's up today? Well, we've got more trig derivatives to learn, and the idea here is well, let's change these ones into stuff that we know, and hopefully you gave this a go. Tan is sine x over cos x, and so if I took the derivative, this is going to feel a lot like a quotient rule. Derivative of the top, right down the bottom, minus right down the top, derivative of the bottom over the bottom squared, and cos squared is that. And I'm running out of room here. I'm going to have to move some stuff. There, get rid of this, get rid of you, get rid of you. And I can actually simplify this quite a bit, because now on the top I've got cos squared x minus sine times minus sine is plus sine squared x over cos squared x. This is 1 on the top. That's just the Pythagorean identity over cos squared x. Well, what's 1 over cos squared x? That is secant squared x. So the derivative of tan is secant squared x. Who'd have thunk? And how I'm going to do this one is, again, write it as 1 over cosine squared, and I'm going to think of it like this, right? Not like that. That looks like the inverse. I want to think of it as the reciprocal, like this. So the derivative is negative cos x, then minus 2, but then the derivative of the inside thing, the derivative of cosine is negative sine x. And tidy this up a little bit. The negative and the negative sign times negative sign will cancel out. Sine then is on the top and cos squared on the bottom. But let me split this up, because I can see I can simplify this a little bit more too. You see how I have sine x over cos x? Well, that's tan. 1 over cos x is secant x. So the derivative of secant x is tan x secant x. And the other ones are similar. You should practice them. Practice your quotient rules, etc. But you should get these rules. Oops. Derivative of cosecant is, oops, is cotan x cosecant x. There's some pattern there, right? And the derivative of cotan is negative cosecant squared x. So do I have to memorize these? Well, that's up to you. I usually don't, by the way, because when I have to, I'll go through these steps real quick, and then I'll be able to write these down. Now, we're going to use them enough today that probably you'll remember them anyway. So that is up to you. Couple of examples. Just all we're doing is applying our derivative rules with these new rules that we just learned. Try and get these out of the way here. So this one is a chain rule question. All right, the 7 hangs out front. The derivative of tan is secant squared of the inside thing, but then I got to take the derivative of the inside thing. That's 8x, and tidy that up. Done. That's it, right? Just a plain old chain rule. Some of these will be able to simplify. This one doesn't simplify much, right? Secant, I could write as cosine. If that helps us, does that help us? I don't know. Don't think so. This one is a quotient rule, right? So derivative of the top, right down the bottom, minus, right down the top, derivative of the bottom, derivative of the bottom, derivative of tan. You got it memorized yet? Secant squared x, all over tan squared x, right? The bottom squared. Could I simplify this? Well, maybe. You could goof around, but here we're just asked to take the derivative. Um, this might be as simple as we get. So I'm okay with leaving it there. Um, if you don't get the same answer as the back of the book, it might be that they use some trig rules and simplify a little bit, but for the most part, we just want to make sure that you know the basic derivatives and are able to apply the derivative rules. All right, that pretty nasty chain rule, chain rule, chain rule, chain rule. So let's try it. The derivative of the first outside thing on of the box is 1 over the box. And then the derivative of the box is, well, notice that I kind of have, even though it's hard to see it, I have inside here the tan of bracket to the exponent 4. So the derivative of this with respect to x, I got to bring the 4 down, and then that becomes 3, and then I still have the inside thing. So I have 4 tan of x minus pi over 2 to the exponent 3. But then I got to take the derivative of the inside thing there. Here the derivative of the inside thing there is just 1, so I guess we're starting to poop out here. But is there some simplifying I can do? Absolutely, there's some simplifying I can do here, because there are 3 copies of tan of x minus pi over 2 and on the top, and 4 on the bottom. So I have then cancel, just 4 on the top, tan of x minus pi over 2 on the bottom. I'd be tempted to use some sort of, I goofed, because when I took the derivative of the inside thing here, notice I just checked my notes and I made a big goof. Go back. Yeah, rest all goofed, but he caught it. So that's good. The derivative of the inside, I went to the derivative of the inside thing, which is 1. The derivative of this inside thing, well, look at this. Right here, what's the derivative of this thing? Well, the derivative of tan is secant squared. And then the derivative of the inside of that is just 1. Right? So the derivative of tan is secant squared. Phew, okay. Now if I tidy, I can still tidy in the way I said before. This cancels this, and I'm left with 1 over tan of x minus pi over 2 there. But then I have the 4 on the top, but I also have secant squared of x minus pi over 2. Now, can I simplify that? Feels like I can. Notice tan on the bottom is sine of that over the cos of that, which looks terrible, but that's going to flip up to the top here. Secant squared is 1 over cosine squared of that. And see, when that flips up to the top, I will be able to simplify 1. So this one wasn't so bad to simplify. Well, a little bit. It was a little bit bad. And then there's 1 on the bottom instead of 2. Okay. And in fact, if I wanted to go further, this thing on the bottom looks a lot like this, doesn't it? which there was a rule. There was a trig rule. There was 2 sine A cos A, which is equal to sine 2A. So if I had that, this would be equal to a half of sine 2A. So if I wanted to, and maybe I want to, maybe I'm done with trig identities for now and I want to quit, but I could write this as sine of 2A, and the A is that. Notice this half, I can flip the 2 up to the top. Then I'm left with sine of 2x minus pi on the bottom. And maybe that's the easiest. And that's a pretty, from where we started, pretty nasty function, pretty nice derivative, really. And certainly, I bet you I could use some sort of rule and simplify that as well. A sine function moved left is probably some sort of cos function or some sort of simpler function, but I'm going to stop there and let you start your homework and the review. We've got a test coming up soon, our last calculus test coming up soon.